Hello everyone. Uh, Now I plan to do something. Somebody had suggested that we should do something using an IC, and we will be using a 555 IC at the moment. Okay. So apart from 555 IC, that is the U1. This is the timer IC. We will need a 9 volts battery. We can use a lower voltage battery also, no problem. Uh, I'm saying no problem because you can use Tinkercad to work on this thing, and you can also use your physical connections, physical ICs, and so on. Because IC 555 is available in almost all the kits available on Amazon, and all these capacitors and resistances they are available. So that is not a big problem. So you can do this physically. You can do it on Tinkercad. Both of them. We'll start with Tinkercad first. So we need 10 microfarads, 16 volts polarized capacitor. We need a red LED or any other LED, that doesn't matter, we just need to blink it. Uh, we need 47k ohms resistors, two of them, and 470 ohm resistor. Okay, how do we create the circuit? This is our 555 circuit, IC in the middle. It has 8 pins starting from this side going on to this side. So this is pin number 1 and this is pin number 8. Now there are a few pins which are directly connected to the ground or positive. So let's figure them out. You know that we have connected the positive to all the railings here, the negative to this entire railing here, positive to that railing also, and we did not need any negative from that side, so we have not connected any negative on that side, so no problem at all. So let's see which pins are directly connected to ground or positive. So pin number 1 is connected to ground directly, so pin number 1 is grounded, no problem. Pin number 8 is given power, that means it gets full power, that is 9 volts. There's another one which is called as the reset pin. This is also directly connected to the positive. So out of the 8 pins, three pins are gone, and we are left with 5 of them. Let's see the rest of them. There is a pin which is not connected at all. So pin number 5, which is control voltage, is not connected at all anywhere. So let's forget about that. So only 4 pins are left. Out of those, pin number 2 and pin number 6, they are directly connected. Okay, so this is the wire that is coming from pin number 2 and pin number 6. In almost 90% of the cases of 555 timer, you will find that pin number 2, which is the trigger, and pin number 6, which is the threshold, they are connected directly. So pin number 2 and pin number 6 are connected directly. Yes. And the connection between the two of them is also grounded through a resistor. And that resistance, through a capacitor, and the capacitor is 10 microfarads capacitor. This is the capacitor which I'm talking about. So it is grounded through that. And basically, this is the capacitor which basically sets the timing for the blinking of the capacitor. All right. So pin number 2 and pin number 6 are directly connected, and the connection between 2 and 6 is also grounded through the capacitor. So that means capacitor's positive side is connected to the connection between pin number 2 and 6, that is the trigger and threshold, and that is the positive side, and the negative side is connected to the ground. So that should not be a problem. Next is pin number 6 is connected to pin number 7 through this resistance. So there is a 47k resistor, which is the which is the connection between pin number 6 and 7. And pin number 7 is also connected to the positive using a resistance. Okay. So pin number 7 is also connected to the positive using a resistance. So I think we've done all the connections. So pin number 2 and 6 are connected and also grounded through a capacitor. Pin number 6 and 7 are connected through a resistor, that is this 47K resistor. And pin number 7 is also connected to the positive voltage using this 47K resistor. So all the connections done except for the output now. The output actually comes from the out pin, which is pin number 3. So pin number 3 is connected to the positive of the LED through a resistance. This is the resistance which actually is 47 ohms, and that resistance goes through the LED and down to ground. Okay, so this part done. Let's start the simulation, and when we see the simulation, it is blinking almost at the rate of around 1 second. All right. Let me change the capacitance of this particular capacitor. Let me make it as 5 microfarads, and let's see how the blinking happens. The blinking has become faster, faster, faster. So that means the lower the capacitance, the higher uh, the faster the blinking. So let me make it as 20 microfarads, and you will find that the blinking is now very slow. It was blinking, yes, but it is very slow. So I think this is a very simplistic kind of a circuit which you can make it on Tinkercad. You can also make it physically using components which are normally available. You can use a lower voltage battery also. I've changed the battery to 3 volts battery. So this is basically containing two batteries of 1.45 volts each. So, and we can just test the simulation. It still works, although the brightness is a little low. Let me do it with a single battery and see what happens now. And the, yes, it works, but the the intensity of brightness is less. I think we should have it as 3 volts or above. That means maybe with 3 volts, that is 4.5 volts now. Let us see how things work. Yes, it is quite bright. So it also does not matter much whether you're using a lower battery or a higher battery. It will still work, and all the components are available. You can create them physically also, and if you have any problem, just let me know. Uh, I can work on a one-to-one basis with you. Okay, that's all for this video. Thank you, and we'll meet in the next video.